Thank you very much. Appreciate everyone coming out first thing this morning on the second to last day of reInvent, especially after an amazing keynote. It's a tough act to follow. So I will do my best. I want to just say good morning. My name's Chris Kopinski. I'm a business development leader within a group we call AWS Industry Products. I support manufacturing, operations, and life sciences. I've gained over a decade of experience working in different areas of complex design, manufacturing, and supply chain before I joined AWS. And in AWS, I lead our business strategy, go-to-market, and customer alliances for the group. We work with innovation. A little bit about our team, we work with innovative leaders, industry leaders that are trying to transform their business with new industry solutions. So today I'm going to give you a presentation around how we approach these type of problems and give you some ideas that you can essentially bring back to your organizations on how to optimize production scheduling for flexible manufacturing, which is a very hot, dynamic topic for us today. So we're going to cover, in this short amount of time, 4 key topics. I'm going to share a little bit about the industry challenge that we're seeing. I'm going to give a brief overview about the potential of optimization in this space. Many companies are doing it, but we actually see interesting, unique opportunities here. And then share a real-world customer scenario and talk about how we can take next steps to continue this conversation. So creating and scaling flexible operations in manufacturing is really time-consuming. It's complex and it's costly. When you look at and you kind of take a wider lens, there's 3 main key challenges that we face with. One is the increasing complexities. So manufacturers today are dealing with real-time fluctuations in demand, cycle times, and resource availability, which makes it very difficult for them to adequately produce. Manual processes and static systems are still a real challenge. If you go into existing facility today, many of them are still not connected. Many of them are still using, let's say, legacy systems and tools to do scheduling, such as Excel, and being able to integrate those become quite a bit challenge to bring dynamic shop floor operations to life. And last but not least, business priorities continue to evolve. We continue to see competing priorities in this space, new areas like cost reduction coming in, quality, maintenance, and even more sustainability goals that are starting to come in. How do you actually optimize for each of these new business priorities? So before I go into some of the use cases and examples, let's talk about what is optimization. Optimization offers a powerful solution to these challenges that I just described. It's a proven mathematical approach in the field of prescriptive analytics that uses specialized software called solvers to simplify decision making. So an optimization model translates key business problem characteristics into mathematical terms. These include objective functions, decision variables, and business constraints. And the solver then processes these models to find the optimal solution. To give you a very simple example, think about where you're going to go next from your next session in reInvent, how you're going to go from, say, a session here in Venetian to Caesars Forum. You could actually go on the app that we provide, and you'll see that there are 3 different ways you can get there. Each of them have calculated times, whether or not you're going on a shuttle, you're walking. Optimization can help you choose the best optimal path and solution for yourself based on the objective function you're creating. Let's bring it now closer into the shop floor. If you think about these challenges, we can leverage what is essentially capabilities that are brought into advanced operations research today into actual production use. So across these categories, I'm not going to go into each one, but you could think about some of the areas where production scheduling optimization can come into effect. Give you an example, optimal economic order quantity is a big area for many of our customers. How do you actually determine what is the right level of production batch size that you can manage, that you can take on to keep your schedule intact while changing and looking at different demands, looking at ordering costs, thinking about holding costs, thinking about inventory availability, understand this stock so you can minimize the impact of cost while ensuring you have the right level of stock. Another one, equipment data. Today, scheduling typically doesn't involve integrating information about what's happening on the shop floor, such as equipment availability or the performance metrics of the equipment. You usually plan to a static plan. you determine what's the best outcome, and you run that plan. Actual is usually different from what is real, so actually integrating that data in real time is another opportunity. And last but not least, many of our companies have sustainability goals. How do we leverage energy consumption goals when we're thinking about improving the energy usage in a plant? Some of our scheduling operations can actually occur not necessarily during optimal peak time. You can maybe schedule some of your operations off peak. You might want to incorporate optimizing against some of your corporate goals around sustainability. So I want to paint a customer scenario, give you a real world challenge that we see. Working with a large automotive manufacturer, this particular customer is faced with significant production scheduling challenges, primarily due to competing, changing demand, cycle times that are not reflective of what's actually happening, labor changes, resource availability challenges, all of that which actually results in real financial impact. So think about the type of costs that get associated with some of these challenges. You could think of overtime costs being added if you're adding an extra shift or a weekend shift. You could think about the amount of costs it might take to expedite that material, whether or not you're bringing inventory in or you're sending your finished good out. The actual cost can really scale depending on if you're going from freight to air, as well as then the lost opportunity cost of what downtime has by not being able to meet your customer demands. AWS can help enable that proactive solution by making scheduling more adaptive, essentially maximizing efficiencies while reducing the costly downtime. We can essentially plan what is actual output to what is predicted output. In this particular case, we can leverage IoT services, also using some of these standards, which I'll talk to you a little bit more about in the example, and bring these into analytic engines that use mathematical optimization to provide these prescriptive recommendations. The impact is significant, particularly the goals for this type of customer may be to have full visibility over your production plant and may be able to reduce that expected overtime that you might incur, increase that on-time delivery, and expedite or reduce the costs associated with expedited parts as such. When we think about this holistically, you really want to gain that availability of all this information immediately when you're standing up your production operations. So I invite you to kind of take a step back. Imagine a world where manufacturing operations optimizes themselves in real time. Many of you, if you operate or work with manufacturing, that's not a reality today, but maybe one day it'll operate as if it's magic. What would you like to see there? You would want to see your systems detect issues instantly. You'd want to analyze millions of scenarios in seconds, and you'd want to implement the optimal solution before the problems even actually arise. You'd also want it to continuously learn and adapt. Can we predict when maintenance needs are going to be occurring that we have to take our equipment offline? Can we adjust to the demand changes and optimize against energy uses? It's like your entire factory has come to life. And we want to work towards perfect harmony where we're actually maximizing efficiencies, improving quality, and leveraging and enabling a sustainability goal. It doesn't have to be science fiction. I know it is today in many of our operations, but this is where we hope to leverage the power of AWS to bring this life, create a truly smart factory, and make it possible to transform your operations today. These are some mock-ups we've done around the experience that we'd like to enable for our customer. So that experience can include basically democratizing those specialist skills. If you're in your organizations, you probably have advanced operational research doing these complex optimizations. We want to be able to bring that into a very simple tool to ingest into your production scheduling, leverage Gen AI interfaces, and prescribe the outcomes that you're seeking, whether it be optimize for reduced costs, whether it be optimized for minimal energy consumption, or optimized for reducing that overtime spend. We also want to use real-time information from intelligence devices. So many of you in operations, if you've experienced this, you have your initial plan. This gets set usually at the beginning of the week and updates infrequently throughout the week. We want to actually look at what's actually happening on the shop floor, what is the performance of the different cells or different equipment, and actually use that information to provide insights so you can recommend back improvements to your schedule and provide different scenarios that could create an optimal schedule. And last but not least, once that optimal schedule is determined, you want to be able to quickly select that best schedule, bring it back into your scheduling system, whether it be your ERP system or if you're using a different tool outside of that, be able to implement those actual updates to those adjusted schedules in real time or as frequent as possible. We don't want to remove the human in the loop, we just want to enable them to make smarter decisions. From an architecture perspective at a very high level, it's really 4 simple components that we see this solution enabling. So one, you're looking at an edge collector, gathering this information. In these particular scenarios, we're working with customers that have adopted OPC UA. This is a standard that brings information models that gives you more contextual information about the equipment to life. Euromap's an example of a companion spec that can be used for equipment such as extruders, dies, line status. That edge collector could bring it back along with that information contextualized model and embed that into your optimization engine. From there, the optimization can actually occur where you're detecting from what was your initial schedule to generate different alternate solutions in scheduling that could be fed back to your production scheduler. So giving them the ability to think about what are those different objective functions that I want to enable, such as cycle time, changeover time, or OEE as a target that allows them to adjust operations in real time. This is a bit of a high level architecture, but again, just to kind of give you a little bit more flavor of the type of solution we're creating here for our customer, what's not depicted here is the IoT services, but you can leverage IoT services to ingest that data, enable that information model, and integrate those servers that are occurring on your shop floor to collect, process, and monitor those equipment into, say, a S3 database where you can actually bring near real-time contextualized information data with your scheduling. You can leverage something like EventBridge, which will allow you to trigger actions based on real-time events, whether it come from the shop floor or whether it come from updates in that S3 environment to then enable that real-time responsiveness for the optimization models to work. You could then also bring those optimization models. There are many open source models out there, but we also have commercial available ones from like Garobi and FICO that we could then bring into allowing for quick, rapid optimization, deploying those with Lambda functions and bringing those, let's say, process capabilities together to run those models, update the production schedule, and integrate those libraries into your overall solution. I went through that fairly quick. These are lightning talks. I absolutely want to continue this conversation. I want to have a deeper conversation with you. I do invite you to come visit us within our kiosks here. We don't currently have a demo, but I'd be happy to set one up with you with our team offline. You know, post reInvent, after you've had a chance to go back and dust off all the notes and think about all the sessions you have, I'd welcome you to contact me or my team to deep dive on your particular challenges. We have the ability, we can demo some of our concepts and explore some of the use cases and case studies in more detail, and we could help you summarize what your business opportunity and goals are for your organization. Ideally, if we come out of that, we can help you with potential use cases, look at high-level architectures, and scope a pilot project for you. For me, contact information is there. Welcome you to email me. Welcome you to look me up on LinkedIn. I'd be happy to continue the conversation. Thank you very much.